Okay, everybody, this is section 10.5. This is dealing with area of a polygon again, but we're going to need to use trigonometry for this. So in section 3, we are doing the same thing, but we were using special right triangles for that. And we were given a pothom and a side length to get perimeter. Now we have to do a little bit more work. So first thing we got to make sure that we remember is SOHCAHTOA. So remember sine, cosine, tangent, and we have this to help us with the trig function, and then what sides of the triangle create the trig function. So you might want to remember that, and hopefully we'll get through this. This is another one where we're going to have to do a lot of work here. So if you need to, make sure that you pause it every once in a while to do it. I'm going to go through this as quickly as I can, but once again, if you're having issues, make sure you email me and we can get together and talk about it, okay? On this one, just take what they're giving us. They're telling us that the side length is 6. And remember, too, over here to the side, to get the area of a polygon, is going to take the apothum times the perimeter, and I like to divide that by 2 instead of multiplying by 1/2. So right off the bat, I need the perimeter. And I know that this is a pentagon, so there's 5 sides. I can multiply that by the side length of 6. So right now I got half of what I need. I got the perimeter being 30, okay? But remember, this is inside of a circle, so from the center, I'm going to draw a straight down and create a right angle perpendicular to that side. You go ahead and you draw in the radius, and then it gives you your triangle that we're going to use to get what we need. I need to get the apothum, which is going to be this. And if you remember, there's a central angle that's drawn here. So to do that, I had to go 360 divided by the number of sides. In this case, it was 5. And that gets me 72 degrees. That's this whole angle up here at the top. Okay? But I'm dividing that in half. So really, I'm going to work with an angle that's 36 degrees. Okay? So I've got this side down here, but when I drew this right angle in, it split this up into 3 and 3, okay? I need the apothum. So using my trig now, I'm going to use this angle, 36 degrees. This 3 is the opposite side. I have it, but I need the apothum, which is going to be the adjacent side, okay? So using my trig, SOHCAHTOA, I have the opposite side. I need to find the adjacent. That gets me tangent of 36 degrees equals the opposite side over the adjacent side. And that's the apothum. Okay, so we'll do that. All right, so hopefully you got your calculators. You can hit pause and do some math here and figure this out. I'm just going to keep on going. So tangent 36 comes out to about 7.7265 equals 3 over a. Remember, if the numeral and the fraction's on top, we're going to go ahead and divide it by the decimal. And a is the adjacent, or the apothum, whatever you want to call that now, rounds out to about 4.1. Okay. So I got the apothum now. I found the perimeter a second ago, or a little while ago now. I'm going to go ahead and plug it into my formula. So the apothum 4.1, the perimeter came out to be 30, and divide that by 2. And I end up getting about 61.5. And in this case, this was centimeters, so centimeters squared. Okay, so a little bit of work going back to chapter 8, using our trig, so we might need to go back and look at that a little bit more. Okay, we're going to go here now. This example number 2. They're telling me that I have a radius of 8 in this octagon, so I'm going to go ahead and draw my triangle in here. Show that it's right. Remember, the radius is this hypotenuse, so you might want to be able to associate those two together. Okay. When they give me radiuses, I got a lot of work to do. So just know that this one's going to take some time. If they give me the apothem and they give me the side, basically they're giving me half of what I need. When they give me a radius, they're not giving me anything. I have something to work with, but I got a lot of work to do. Anyway, got to find that central angle again. So 360 divided by 8, okay? That's going to get me 45 degrees. But remember, I'm cutting that in half, so really I got to divide that by 2, and it gets me this angle right here is going to be 22.5 degrees, okay? I need to get the opposite side, because that's going to help me get the perimeter. I need to get the apothem, or the adjacent side, okay? So I can't do tangent here because I don't have one or the other. So I've got to go a little bit at a time. I'm going to find the opposite side first. Now remember, this 8 represents my hypotenuse. So if I have the opposite side I need to find, I have the hypotenuse is 8. That's going to get me sine of 22.5 equals the opposite side. I don't know what it is. I'll call it x over the hypotenuse. Okay. So if you want to pause it now, you can do a little bit of your math. You know, I'll keep going. So that's going to give me 0.3827 equals x over 8. Because the number's at the bottom, I can go ahead and multiply that. I'm going to go ahead and get 3.1. Okay, now we have to be careful here. That 3.1 is this, and I need the perimeter, but remember I split this in half, so this is 3.1. So my side really is 6.2. To get the perimeter, then I'm going to have to multiply that by 8. Sorry about that. Hold on a second. I'm going a little too fast. That's going to get me 49.6 for my perimeter. Okay. All right. But I still need the apothem. So that's going to be this side again. I'm still going to use the hypotenuse. All right. So that's going to cause me now to do cosine of that same angle, and this time it's going to be the apothem over the hypotenuse, or the adjacent side over the hypotenuse. Okay, so once again, you can pause it and do a little bit of your math. Cosine 22.5 gives me 0.9239. That equals the adjacent side over 8. Once again, if the number's in the bottom, I can go ahead and multiply. And I'm going to get the apothem is approximately 7.4. Okay, just a little bit of math there, but now I got a perimeter. I've got the apothem. I can go ahead and plug this into my formula. So 7.4 times 49.6, all divided by 2. That should get me about 183.5. And the measurement they gave me here was inches, so inches squared. Okay? So, like I said at the beginning, if they give me a radius for something, I got 2 trig functions to do. So typically that's always going to be sine and cosine, because those are the sides you need, the opposite and adjacent side. The radius is always the hypotenuse. Okay? So think about those things before you start the problem. What do I really have to do here? And you might be able to help yourself out with your, at least your train of thought. Okay? Okay, here we go. This is a regular decagon with an apothem of 14. So they're giving me part of what I need. Thank you very much. I'm going to draw that triangle in, show that this is 14. Okay, so really I need this piece right here, okay? So once again, I need the central angle. So 360 divided by 10 in this case, decagon, gives me 36 degrees, but I have to divide that by 2. Means that this is going to be 18 degrees up there at the top. Okay. So if I need this side, that's going to help me get the perimeter, and they've given me the adjacent side. So I've got opposite and I've got adjacent. So that's going to give me tangent. So tangent 18 degrees is going to equal the opposite side. I called it X. Over the adjacent side, that's 14. And then you could pause it and do your math here. Tangent 18 gets me about 0.3249 equals X over 14. Once again, the numbers down at the bottom, I can multiply that out, and I'm going to get X is about 4.5. Okay, but remember, that's only part of this side. So really, I got to double it to get the whole side, and that's going to add up to be 9. And since it's a decagon, 10 times 9 is going to give me a perimeter of 90. Okay, so now I've got the perimeter. I had the apothem, that's what they gave me at the beginning. So I can go ahead and go, the area equals the apothem times the perimeter over 2. And I get an area of about 630. And in this case, they told me it was centimeters squared. Okay, so when they give me an apothem, when they give me a side length, it's really half of the battle right there. And we just got to remember how to do our trick. Okay. All right, last one. This one gets a little bit tricky. Once again, there's a couple different ways to do this one because it's an equilateral triangle. I'm just going to stick with what we're doing. So they give me a radius of 6, so that's telling me I got a little bit of work to do here. But watch this. Once again, if you remember that an equilateral triangle, all the sides are the same, so therefore all the angles are equal. So there's 60 and 60 and 60 down here. But I split it, so 30 and 30, and then all of a sudden I think I got a 30, 60, 90 triangle, okay? So remember, if this is a 30-degree angle, that's the short leg. This is going to be the hypotenuse, the radius, so I'm going to go ahead and cut that in half. So that's going to be 3, and then this side down here at the bottom is the long leg, because this is 60 degrees here. So this one I'm going to get 3 square root of 3. Okay. This would also be 3 square root 3. Okay. So now I can take that 3 square root of 3. All the sides are that, so I can multiply that by 3 to get the perimeter. I'm going to get 9 square root of 3 as my perimeter. This 3 back here that I got when I took half the hypotenuse, that also now becomes my apothem. And now I got everything I needed. So if you remember your special right triangle stuff, that was pretty easy, I think. Okay. Find the area is the apothem times my, I'm sorry, I screwed up back here. Let me go back. This should be 6 square root of 3. I'll look at my notes once in a while. So that gets me 18 square root of 3 is my perimeter. Sorry about that. And then I'm going to divide that by 2. Okay. So on top I get 54 square root of 3 divided by 2 gets me 27 square root of 3. Okay. I could leave it like that, or I could go ahead and multiply it out. And that would give me about 46.8 when I multiply that out. Okay. All right. So that's regular polygons. Find the area you need, hypotenuse and perimeters. Sometimes we give it to you, but you know, we got to work at it sometimes and be able to find them and find the pieces you need. Okay, so hopefully took good notes. Keep looking at it. This is going to be important stuff for you for when you get into higher math. Okay, thank you.